Alright, in this video we're going to take a look at series circuits and how they work. It's kind of a follow-up to the Series Circuit Lab. Now if you take a look at the circuit we have built, we have a 3-volt power supply connected to three 1K resistors in series, meaning there's one path through them from one side to the other. Now in your lab that you just completed, you had to take some measurements. You took resistance measurements, voltage measurements, and current measurements. So let's take a quick look at how you accomplished that. To measure the resistance of the three resistors, you disconnected your battery, made sure that you at least took one snap off the battery so you weren't measuring the resistance between the battery, and you set your meter and you measured. The first one was about 996 ohms, the second one 980 ohms, the third one 989, and then the total, which is from one side of one to the other, about 2.964. And if you looked at the relationship, you would have seen that the total resistance of all three together in series is just the individual resistances of the three resistors added together. So we can come up with rule number one for series circuits, and that is that the total resistance of all the objects in series is equal to the sum of the individual resistances. Okay, and then the second part, you measured voltage. So we change this to 4 volts. I know my 3-volt setting should be sufficient. Plug that in. Make sure that current is flowing. And then you see that the voltage across your battery, the total energy you supplied, is 3.3 or so. And the voltage across each individual one should be about 1.1. 1.1, 1.092, 1.103. So almost all exactly 1.1. So the rule about voltage in series circuits that you should have found is that the total voltage of the battery is equal to the individual voltages measured across each individual component, in this case the three resistors. Now the last thing you looked at in this lab was current, so let's change our meter over to measure current. And you can say, well, current flows out of one side of the battery back to this. So if I want to know the current flowing into the first one, I got to disconnect the circuit and make sure I make my series connection so that the current flows through my meter now. So here, in this case, I have about 1.08, about 1.1 milliamps going into the first resistor. So then I take off the connection to the second one. I got 1.078 milliamps going into the second one. Into the third, again 1.078 milliamps flowing through it. And for the last one, 1.078. Well, so what does that tell us about current? Well, what it says is that in a series path, in a series circuit, this becomes rule number 3, the total current flowing through the circuit is equal to the current flowing through each individual item. Or another way to think of that is the current is the same. Okay. Whereas the total resistance is the combined adding up of three resistors, or however many you had in series. If it was just 2 in series that we had and connected them, it would just be R1 plus R2, or V1 plus V2 for the voltage. But the current would be the same throughout. And those are your series rules for how resistance, voltage, and current act when in a series circuit.